Hello. In this session, we'll go with Schrödinger's wave equation. Schrödinger's wave equation is a very special, very interesting, very important for quantum mechanical model of atom. It is the fundamental equation for quantum mechanics. Quantum mechanics means the orbital concept. It is based on de Broglie's concept and Heisenberg's concept. According to de Broglie's, all the microparticles will be having dual nature. All the microparticles moving with high velocities will be having dual nature. Electrons, protons, neutrons, all these you can say they are having wave nature as well as particle nature. And second thing is Heisenberg's uncertainty principle. It is just impossible to determine the exactly position and the exact momentum of subatomic particles moving with high velocity. Okay. Based on these two, we have a fundamental equation for quantum mechanics which is known as Schrödinger's wave equation. When it comes for the JEE and NEET exams, okay, Schrödinger wave equation is very important, of course. JEE NEET, very few chances are there to ask in the exam, and that too very few lines generally they ask in exam. About all those we'll discuss now. Schrödinger's wave equation is a three-dimensional concept of moving electron. Okay, about a moving electron we are giving, and it is a second order partial differential equation. Schrödinger wave equation is a second order partial differential equation. Just remember these lines, and the equation is dou square psi by dou x square, dou square psi by dou y square, dou square psi by dou z square plus 8 pi square m by h square into e minus v into psi is equal to 0. Dou square psi by dou x square plus dou square psi by dou y square plus dou square psi by dou z square plus 8 pi square m by h square into e minus v into psi is equals to 0. Here psi is wave function. Psi specialty is it has no physical significance except that it shows the amplitude of electron wave function. Okay, now when we are discussing about the electron wave function, we say this is the amplitude, height of the crest or depth of the trough. This amplitude is nothing but the psi, or you say wave function. That is psi. E is the total energy of the electron. V is potential energy of the electron. So E minus V will be the kinetic energy. E is total energy, V is potential energy. So E minus V will be the kinetic energy. H is known to you, Planck's constant. M is mass of the electron. Dou squared psi by dou x square. X, y, z we are taking here. These three are three different axes, you can say. Cartesians, x, y, z. Dou squared psi by dou x square plus dou squared psi by dou y square plus dou squared psi by dou z square plus 8 pi square m by h square into e minus v into psi is equals to 0. Even this expression is not equation as it is not mentioned in the NCERT. So don't worry much about this. This equation, if you take psi common here, dou square psi by dou x square, this I am taking out, okay, plus dou square by dou y square plus dou square by dou z square into psi, okay, now plus 8 pi square m by h square into e minus v into psi is equal to 0, you can write. In place of this dou square by dou x square plus dou square by dou y square plus dou square by dou z square, we can write del square. You can say this is nabla also, del square, del squared psi. In place of this I am writing del. Okay, now del means dou square, del square means dou square psi by dou x square. This psi is not there. Dou y square plus dou z square. Nabla, or you can say del squared psi plus 8 pi square m by h square into e minus v into psi is equals to 0. This is a mathematical expression. You can make it even more simple. That simple, and I will tell you. On LCM and further simplification, you will get finally the expression like this, E psi. I add this in description if you want, is equal to V minus h square del square by 8 pi square m into psi. And here simply we can write E psi is equals to, in this place I am writing H cap psi. Just you see, from this expression on simplification we are getting E psi is equals to V minus H square del square by 8 pi square m into psi. In the overall this place where I am writing as Hamiltonian operator. H cap is called Hamiltonian operator. Whenever we are writing like this an operator, that is a mathematical operation you can say. For if you are doing any multiplication you can write m cap. If you are doing any division, d cap, like that. Here H cap means that is Hamiltonian operator. Okay, so E psi is equal to H cap psi. This expression is given in our NCERT book. So H cap is this one, V minus H square del square by 8 pi square m. Del is Laplacian operator. Okay, now del square we are writing, del square is Laplacian operator. Spellings are little different in different books, you don't worry about the spellings. And H cap psi is Hamiltonian operator. Hamiltonian operator, Laplacian operator and Hamiltonian operator. E psi is equal to H cap psi. If you remember up to this, that's actually more than sufficient. The most important things about this are, when you are going to solve this equation, you will be getting different values for psi. Okay, now, but those values are only considered which are continuous. Psi values must be continuous. This is your question. Okay, this is your question. Psi values must be continuous. Psi values must be single valued, and psi values must be finite. Finite, single valued, and continuous. This is your question. Psi must be continuous, single valued, and finite. This is one very, very important point. As I told you already, Schrödinger wave equation is a second order partial differential equation. Psi means actually we consider it as a representation of orbitals. Okay, now so this is we are taking the Bohr's theory into from orbit concept to orbital concept. For that, this wave mechanical model. Schrödinger wave equation is solved for some definite values of psi to get a set of 3 quantum numbers: principal quantum number, azimuthal quantum number, and magnetic quantum number. How these are given, you see, that is also interesting. When the psi is given like this, psi n comma l comma m values will be given. For example, if it is given psi 2 comma 1 comma 0, psi 4 comma 2 comma 0. When these are given, that means this is n value, this is l value, m value, n value, l value, m value. N value 2, L value 1 means this is 2p orbital. M value 0 means you can take this is 2pz orbital. N is equal to 4 means 4th orbital. L is equal to means d orbital. M is equal to 0 means dz square orbital. You can take like this the exact representation of the orbitals. Psi, N, L, M. When 3 values are given, the first value indicates the principal quantum number, second value indicates the azimuthal quantum number, and third value indicates the magnetic quantum number. This is another important point. But when you are taking the psi sometimes come negative also. This is amplitude. If this is positive value, this will become negative value. In order to avoid the negative value, we generally go with the psi square. Psi square measures the probability of finding an electron around the nucleus. Psi square means the probability of finding electron around the nucleus. So we can say simply psi square is probability function or probability density. And as I told you already, Schrödinger wave equation has several solutions. Some of these are imaginary and are not valid. Okay, so when you are solving this, you will be getting so many solutions. All solutions are not considered. They must be continuous, they must be finite, they must be single valued, and some are imaginary, they are not considered. Only few values we are going to consider. If potential energy of the system is, that is electron, is known, when the potential energy of a particle or an electron is known, then the kinetic energy and psi both can be calculated from this expression. As the distance increases and at infinite distance, okay, now when you are going to infinite distance means the electron is not in the attraction of the nucleus, so at infinite distance psi will be 0. This is again one question to you. At infinite distance, what is psi value? Psi will be 0, that means no probability of finding electron. And two special terms are there. Okay, now not able to ask in question, but statement wise they can ask you. For certain values of E, the energy of the electron E, psi has maximum values and such values are called eigenvalues. Okay, now for certain values of E, that is total energy of the electron, psi will be having maximum values and all such values are called eigenvalues. And for these values of E, that is energy, the values of psi are called even eigenfunctions. Okay, now eigenvalues and eigenfunctions, these are nothing but psi values. Values of psi are called eigenvalues and eigenfunctions. This psi NLM is the orbital representation. It is principal quantum number. This is azimuthal quantum number. This is magnetic quantum number. For multi-electron systems, Schrödinger wave equation does not give exact solutions, but may be solved with reasonable accuracy using some approximations. Not exactly, but you can go with little bit closeness. So what finally you need to remember? What is Laplacian operator? What is Hamiltonian operator? What is the final equation? What is psi? What is psi square? What is psi NLM? And how the values of psi must be. Okay, now I was explaining all this repeatedly. Just go with this, that's enough. Don't worry too much about the Schrodinger's wave equation. It is just a quantum mechanical model approach for us. If you are learning quantum numbers, this will be very much easy. Thank you.